minus 20 degree if you require means the same turbine, only the material and all the other detail icing formation and all this you have to consider. In case you required a turbine for minus 40 degree, then complete turbine you have to use a specific material and the turbine and the heating system also required. In the turbine also a lot of cooling the turbine is the major task actually. If you are going for a turbine above 45 degree, then you have to use additional cooling system design and to get the better performance. So the normal condition, what is the onshore condition and offshore condition. These are all the major for the designing the turbine. And you also consider the ambient. What is the ambient? Air quality. Air quality means if it is onshore and offshore, because of salt content in the air, the external cooling is not possible. You have to provide additionally the internal cooling only, and some cooling system you need to install in the turbine. And also the seismic. Because nowadays the land availability is the major problem. So for the foundation and all this seismic condition also now they are considering in that area also the turbines, some turbines near to the. And near site requirements are also very important. Near site there is any Air Force station or airport, that means you have to provide obstacle light and color coding in the blade to identify the turbine while rotating. And also forest area, if there is any forest area, that noise level, controlling the noise level, and also particular area if there is any bird crossing, then programming to stoppage the turbine that particular time. These things are now the latest standards. They included the near forest area, bird stopping and all these things. If there is any residential area nearby, then the voice control and then the noise pollution and all these things. And also the load condition. Load condition, normally while designing the turbine, what they will do before the wind farm or before the wind farm, the designer will release the complete turbine to the market. What they will do, they will consider only the extreme loads. All these loads and details are specified, and how to take the loads are given in the IEC. As I told, IEC, International Electrotechnical Commissioning, they are already given the norms how to standardize this, and safety norms also. Designer, normally they will consider the extreme loads for the particular wind class. If they specified wind class 3B means based on the turbulence level, they will consider the extreme loads for all the components. So if you want to go for a smaller wind farm, that is nearly less than 50 megawatt or 60 megawatt, 80 megawatt, depends upon the, so they can go for standard design available in the market. If you are going for a big wind farm, 200 megawatt, 300 megawatt, big wind farm, we have to consider only now this is the latest development, site-specific loads. Site-specific load means they will install the mass and they will take the load. Based on the loads, they will go for a design. Not all the component, major variation will be in the foundation and some structures need to modify, and you have to go for again a certification. This is the process. So you have to go for extreme loads for standard design. Site-specific conditions also we have to consider for a specific loads. And the component design. Component design, blade is a separate technology, composite material. The blade, the design of the blade is not possible in a single step mold. Smaller blades up to 250 kilowatt, smaller blades is possible to take out in a single mold. But if you are going for a more than 250 kilowatt, and nowadays it is the blade lengths become 100 meters, 120 meters, 120 meters and 100 meters are available in the market. So it is not possible to mold in a single stage. You have to go over a 3-4 stages, internal stiffness, profile. Based on the profile, we have to give the longer cord length and all. So blade design, normally there is a surface modeling, simulation, and then blade, again separate blade, we have to go for a testing and certification to withstand to the particular wind speed. And up design, as I told earlier, pitching control, pitch is very important. When you want to stop the turbine during the high wind or in that time, pitch control is the first. They will act as a brake. So normally pitch control a little bit complicated. Why? Because in case of there is no power, there is a power problem. There is no external power available. Turbine also not rotating when it is a high wind time, means the controlling the pitch. Normally that designer, they will provide the batteries inside the pitch control system. They will have battery electrical backup. Some manufacturer, they will provide the batteries. Some manufacturer, they will provide the capacitor. Some power backup. Pitch control design is very critical. To stop the turbine, to control the turbine, pitch design and pitch control design is important. Nasal design. Nasal design, actually nasal contains the generator, gearbox, everything. Nasal is a normal structure. If it is a conventional method, then the gearbox and generator. The gearbox, various nowadays various gearboxes available. Now the generator also various models, designs available. These gearbox and the generators are standard one. Lot of manufacturer, they are producing only for windmill generator and gearboxes. Based on your requirement and designer requirement, the manufacturer will procure the gearbox and they will install the turbine. The coupling also, there are various new technology in the coupling system and the bolting system. Bolting, these four are critical for the bolting system, bolting connections, and this is for the conventional drive. The comparison to the nasal design for the conventional and direct drive. Direct drive, the complication in nasal is less because there is no gearbox, so only the generator and the converter. Normally they will keep it in the ground only. So the nasal design for the direct drive is simple, but compared to the conventional and the direct drive, conventional is having the gearbox, direct drive will have the converter. Mechanical components are more in the conventional one. Direct drive, electrical components are more. This is the major difference. And also for the tower design. Tower design, nowadays class 3 and class 4 sites are available. So it requires more height. So normally now at present 100 meter, 120 meter is the requirement for the tower. So various technology available. Concrete towers are nowadays, a lot of the manufacturers, they are using concrete towers and concrete to steel hybrid towers, and combination of concrete to steel, some up to 50 meters, 60 meter height, they will go for concrete, and above that they will place a steel tower. In the tower also, steel tower also, lattice is the old one for smaller turbine. Tubular is for higher megawatts, and concrete to tubular and lattice to tubular combinations are available. This is only to reduce the cost and to achieve the higher heights. Foundation also nowadays, if it is a land or available land is having the sufficient bearing capacity, then they will go for normal foundation. If the foundation, the land is near to the water area or soil condition is very poor, then they will go for piling and also raft foundation. This is depends upon the availability of the land. And for the component design, the manual calculation for rotational equipment and all these things. Structural, there are simulations, softwares available for structural calculation. Blade, generator, it will have will go for electromechanical and simulation. And all the structural, normally structural means the foundation, tower, these are all structures. And in other components also there is a structural available. And for the other things are rotational component, gearbox, generator, and hub. These are all rotation component. The individual blade considered as a structure only. They will do individual blade only. If it is coupled and coupled with the turbine, then it will have a rotating loads and all these things. This is the solid modeling, and also the blade internal stiffness. This is for the smaller blade. In case of if you go for a 100-meter blade, 120-meter blade, you required to mold in a 3-4 stages, and internal stiffness are more. And based on the wind condition and turbulence level, the profile also will vary. For all these things, actually, the project management is very important. Why project management is critical for wind turbine is you cannot install the turbine throughout the year. Installation of turbine only possible in a particular wind period only. If it is a high wind, it is not possible to do any erection activity. That is the major drawback in wind industry. So suppose if you are having 1 month or 2 months particular time low wind, that time only you have to do the wind projects. So high wind season, it is not possible. But site activity like foundation and other activity, transmission line, we can do the simultaneous site activity. But because of this only, project planning is very important. Project planning engineer and project planning team, they will simultaneously, they will start the site activity and manufacturing activity. And because of component size is very huge, and the planning, and also there are challenges in other transporting and other things also. So project planning, and this is very important, and project planner will give you the instruction when to start the site work, when to start the manufacturing activity. To start the manufacturing activity, all the manufacturing facility, they require from the designer, they will provide the drawings, the manufacturing drawing, and also with bill of material and instructions, assembly instructions, and then the manufacturing instruction and testing instructions. Individual component testing, complete assembly component testing, and site testing. These are all the manufacturing and testing instructions. And after manufacturing, it requires sourcing. Sourcing also in wind industry is a big team. All the components, manufacturer, OEM, they will produce only the important component. Blade. Some manufacturer will produce a generator. Some manufacturer will do the machining and for main components. Control panels and assembly they will do. And major components they will do outsource only. So when it is outsource means lot of import items and various countries it has to import. So sourcing team is they will source which supplier they have to do the component and alternate sourcing and all these things. So and after then the sourcing, then the supply chain. Supply chain, they will keep the component ready for the assembly, and supply chain and sourcing. These are all fall under the manufacturing and manufacturing control. And quality management. There are various people, they are working for the quality at various stages, incoming inspection, and also on supplier on-site supplier inspection, and during manufacturing inspection, testing. These are all for the quality management. And logistics. Logistics is very huge components. Because of very huge component, there is an internal road transport also critical, and sea transport. Lot of component, mainly blade damages during road transport and shipping, and shipping to the site. Some sites, when it is offshore means, then the different transporting methods are required. So logistics, transporting is the challenging part for the wind turbines because of the component size. Normally, if you take 1.5 megawatt, the blade about 80 meter or 90 meter blade, and then the diameter is around 2 meters. And the component also, if you take a Nasal alone, it will weigh about 50 tons to 60 tons. And each blade weighs about 8 to 9 tons. So because of the size, the logistics is tough. And after logistics, erection. Erection, as I told earlier, erection, it is not possible to do throughout year. Only at the low wind only it is possible. We have to see the low wind condition, and also if there is a rain, or mainly the wind and rain. During the rain condition, it is not possible. Lightning. See, because they are working on a height of 80 meters. After installing all the equipment only, the lighting system, everything will work. So we have to give the safety to the person. So in case of rain and lightning, the erection activity, commissioning activity is not possible. So because of these reasons, erection management is also critical. So these are all the erection of the main components. And commissioning. Commissioning, what they will do normally, the loads, they will verify the initially what is the actual designer given the initial load, consider the initial load, and they will calculate based on this whether it is turbine withstand the particular load and the design load versus actual load. As I told earlier, the power curve. Designer initially they will release the theoretical power curve. After installing the site, they will go for a actual power curve. Take out the actual measurement and actual power curve, comparison of theoretical power to actual power curve to verify whether the annual generation earlier, what they are calculated, it is meeting the annual generation and individual component load. And they will keep for some observation time for maybe some particular sites or particular place required more observation because of more load at particular place. And monitoring actually wind farm monitoring nowadays, manpower reduction of manpower, they will go for a supervisory control, the particular grouping of some turbines, and they will provide one monitoring, and then that turbine they will combine and group it to the entire wind farm, and the entire wind farm connected to the central monitoring station. Central monitoring, they will verify globally for throughout the globe all the turbine, and they will see whether how many turbines are running, whether it's stoppage means they will analyze. And then nowadays, actually, each turbine, they will use nearly about 150 to 200 sensor to various points. They will rectify the error on the monitoring station itself. They will try to run the turbines. And the designer itself, they will provide the set of instruction, what type of error or what type of stoppage you have to start the turbine. Some stoppage, it is not possible to stop the turbine. They have to inform to the site person, they have to go and check and rectify the problem, then only they will run the turbine. So this is the supervisory control SCADA system for the complete wind farm. And also certification. Certification, actually, each wind turbine, each model required a certification. How to go about a certification? So you are having any particular design, you want to do any certificate. What you have to do? You have to set, there are the main standards controlled and released by IEC, International Electrotechnical Commission. They are releasing the standards, and guidelines also available. Some other third parties, they will provide the guidelines also. Standards, and based on the standards and guidelines, first for certification, there is a certification bodies available, various certification bodies available. What you have to first you have to submit your basic design concept, how your design is working. You have to submit, and after seeing the basic design, they will give the detailed design for calculation for each and every component, and the loads, based on the loads, how the component is withstand individual component testing and all the details. They will go for a detailed design evaluation. And after design evaluation, they will go for a manufacturing evaluation. They will evaluate the manufacturing facility and see whether the manufacturer meeting the requirement of the designer. So they will verify. And after verification of manufacturing evaluation, you have to put one particular type of turbine at the site. And at the site, that is called a prototype site, and that site they will verify. The certification body, they will fix the load sensor. They will provide the certified power curve. Initially, I told there is a power curve for theoretical power curve. After the turbine performing, you have to take the actual power curve. In between, all the customer, they will ask the certified power curve. Certified on a particular site, they will do the testing, and they will certify that this much is the wind speed, your turbine will produce this much power. with the power car. They will give you on their own, they will give the certificate, certified power car. They will do the power testing and power quality testing and also noise level testing. And there are list of various testing. These, after doing all these tests, they will give for a final evaluation. And after final evaluation, you will get the type certificate. So it is depends upon the country again. So only if you got the type certificate, you can install anywhere in the world. In some cases, some country, after the type certificate, you have to submit to the government, you have to get the approval. And also to the local, those who are connecting to the grid, also you have to submit the certification and get the approval. Normally, it will go for 3 stages approval for a wind turbine to connect it to the grid for before after commissioning. So foundation is not included in the certification at present. If you required, you will go for an additional evaluation for the foundation also. These are all the certification procedures. And the case study. Case study normally the redesign of the tower. Redesign of the tower based on the site loads. Normally, they will consider only the theoretical load, that is the extreme load condition. Nowadays, class 3 and class 4 sites required 100 to 120 meter tower height. If you consider the extreme load, then the cost of the tower is very huge. So to reduce that one, redesign, and then the main component, if you do then any redesign of main component, you have to go for a certification verification for main components one. And this is the case study for doing redesigning the tower for the particular site loads. And in the same way, we can do the redesign for soil condition. If the soil condition, normally, if you go for 1.5 tons foundation means, it will have a 45 to 50 tons of steel and 350 to 400 cubic meters of cement. These are all the requirements. So if the soil condition is worse, you have to go for a redesign. Soil condition is better, rocky, so you have to reduce some cost in the foundation. So these are all the case studies. And job opportunities. Job opportunities, actually, as I told, wind resource assessment is the first one. Wind resource assessment, a lot of job opportunities available. A lot of third parties available. They will do only the wind resource. They will take the data from the customer and they will analyze and they will suggest better turbines and better spacing, and they will produce with annual energy generation. And IPPs, they will appoint the wind resource team. Manufacturer, they will appoint the wind resource team. And also those who are doing separately for I say only they will do only services for wind resource as a service also. And sales and marketing teams available. These are the teams. So in that various job opportunities, project planning, site project planning, individually project planning, manufacturing, this project planning is also available. Design, each in the design itself, for a Nasal, they will put a separate team, lead and then the separate team, generator separate team, hub and blade separate team, because blade is a different material. So it requires a composite engineer, polymer engineers, and also for the electrical side, actually the design engineer for electrical, and also the IT, all the turbines working in software. So any change for the site or any special requirement, so it requires a software correction. So there is a software available for turbines, each turbine, and communicating the turbine to the supervisory control. There are softwares. There is a softwares are available. And tools also important, because very huge component, transporting sea, transporting road, and storage, and also while manufacturing. So tools engineers are required for design tools engineers. And production engineers, each shop, they will provide a separate shop for generator separate shop and coil manufacturing separate shop, and each shop required a production engineer and supervisors. And production control panels, the pitch control, there is a separate panel, and also other controls, and turbine control, safety chain, and stoppage of turbine. And if there is any person working on the turbine, we have to give the safety for them. For that, there are control panel design and also control panel manufacturing. These are job opportunities available. And blade engineers for production and also for design. Quality engineers, each stage material quality, and also during the testing and final commissioning testing, quality engineers requirements. Very huge component storage, lot of storage engineers, and supply chain is a separate team. Vendor development, always they will do vendor development for a new component and also the existing component. Lot of imports and exports, so they will appoint a separate team for import and exports. Shipping and the logistics are a separate team, and engineers job opportunities. And at the site, actually the substation they will put a separate engineer, transmission line, and also the substation. And the erection engineers is a very huge component. Certification of erection engineers, they have to go for heavy engineering certification, some knowledge about heavy cranes handling more than 300 tons, 400 tons. And commissioning engineers also, there are a lot of requirements. Monitoring, O&M, and certification also, big companies, they will provide a certification as a separate team. These are all the other quality engineers and design engineers.